Okay, let's go over this problem that we didn't get to, which are soluble in water, CH3F, CF4, HBr, NH3, N2. So anytime I see the word soluble, I'm thinking, okay, I have to decide, is this a case of an ionic solute in water, or is this a case of covalent solute in solvents? So water can be either one. Water is covalent. It's also something that ionic solutes can dissolve in. So my first thing is I need to look at these and decide, are they ionic or covalent? An ionic substance would begin with a metal or a polyatomic ion. A covalent substance has all nonmetals. So I see CH3F, CH, and F are all nonmetals. There's no polyatomic formulas in here. Like if it had NH4, that's a polyatomic ion, but there's none in there, no polyatomics. CF4, also C and F are both nonmetals. HBr, H is that tricky one. It's a nonmetal, but sometimes it acts like a metal, but it's a nonmetal, so I have a nonmetal, nonmetal. NH3, nonmetal, nonmetal. N2, nonmetal. So these are all covalent substances. So the key to this question is determining what does the solute have the same polarity as the solvent. I'm remembering that, so I need to see in all cases whether each of these is polar or nonpolar. I know that water, my solvent, is polar. One, I could draw out the Lewis structure of water and figure it out, but I told you on the slide with the common polar and nonpolar substances, you should just memorize water is polar. So I know water is polar. So if any of these covalent molecules are polar, they will be soluble in water. So now I have to go through CH3F. Again, I'd like to shortcut. I'm trying to avoid drawing a full Lewis structure, figuring out a shape, figuring out the polar bonds. So I just want to look to see, could there be polar bonds? I do need to kind of figure out what the general shape might be. And I know that carbon should be the central atom. So this should be something like carbon with hydrogens and fluorines around it. I'm not going to draw the full Lewis structure if I can get away with not doing so. I know that carbon-hydrogen is a nonpolar bond. I've memorized that. I know that carbon-fluorine is a polar bond. So I know I have a polar bond. The question is that enough for the whole molecule to be polar? And the answer is sometimes. If there's a polar bond, the entire molecule will be polar if the polar bonds don't cancel out. For them to cancel out, I would have to have a molecule with the right shape and the right number of identical bonds. Again, I listed as tetrahedral with 4 identical bonds that have to have the same polarity. It could be trigonal planar with 3, or it could be linear with 2 identical bonds. Again, that's back at the end of chapter 6. So in this case, I see that there's a polar bond, and I also see that there's not 4 identical bonds. So it's enough for me to say this is polar. So this would be soluble. Let's do CF4. Once again, I don't really want to draw the whole Lewis structure, but I do need to kind of figure out what bonds, what's bonded to what. I know carbon would be my central atom. So it looks like this thing has 4 carbon-fluorine bonds. Again, I first need to see, do I have any polar bonds at all? If I have no polar bonds, the whole molecule is nonpolar. Here I have a polar bond. I've memorized that this is polar. So I have 4 identical polar bonds. Because I would imagine that all 4 of these are the same. So they're the same polar bond. So I have that 4. So if this is tetrahedral, then it's going to be 4 identical bonds. So I'm thinking it is. I also said, remember, we're looking for symmetrical cases on our common nonpolar, polar and nonpolar substances slide. We said that symmetrical cases like CX4. X could be anything that's going to be a polar one. So this is my CX4 symmetrical. I could actually draw the full Lewis structure, figure out the shape. I can tell you it is tetrahedral. So this is going to be nonpolar. So that would not be soluble in water. Only because water is polar, it can only dissolve polar solutes. HBr. There's only one bond in this. There's only two atoms. There's only one bond. It's going to be an HBr bond. I'm not sure if that one's polar or nonpolar. I might have to look that up. I'm going to take the electronegativities and subtract them, and I'm going to find out that it is. I'm pretty sure it is polar. All right, let's check it out. Hydrogen is 2.1 and bromine is 2.8. 0.7 is enough electronegativity difference. It's between 0.45 and 1.7, so this would be a polar bond. Note that the only way it could have a polar bond and still be nonpolar is one of these three symmetry cases, and none of them, all of them have to have at least two polar bonds, identically polar bonds. So since there's only one polar bond, it's automatically polar. It doesn't meet any of these three conditions because at a minimum I need two polar bonds, identically polar bonds. So this one's polar, so this one would be soluble. NH3. So I see this and I'm thinking, well, N, H, H, H. I've memorized that NH is a polar bond. So this looks like I might have those three identical polar bonds. I definitely have polar bonds. There are three identical ones. The question is, what is the shape? So I'm going to have to actually draw out the full Lewis structure for this. I know that we have a valence of 5 for nitrogen. Each one of these has a valence of 1. 1, 1, 1, 1, 2, 3, 4, 5. So when I'm done, I do have a lone pair on nitrogen. So this has 3 bonding domains. It has 1 lone pair. And if I look on my table for shape, that is not trigonal planar. Trigonal planar has 3 bond domains and 0 lone pairs. This is trigonal pyramidal. So it's not trigonal planar with 3 identical bonds. It only meets the 3 identical bonds part. So it's not going to cancel out and be nonpolar by symmetry. So this one's going to be polar. Polar molecule. That means yes. This is ammonia. Ammonia will dissolve in water. My last one is N2. Now I should just look at that and I know any elements are going to automatically have nonpolar bonds. This is 2 nitrogens. This is one of my memorized cases that if I have an element with just one element, even if it has a subscript, it may be a molecule, it may be covalently bonded, but they're all going to be nonpolar bonds. So this one's automatically nonpolar. If you have no polar bonds, it's nonpolar. So the whole molecule is nonpolar. So this one's going to be a no. So the answer to the question is that CH3F, HBr, and NH3 should be soluble in water. CF4 and N2 would not be soluble in water.